Okay, in this case, we have a function which is defining minus 1, 1, right? And it's a real function, right? And it's an integrable, right? And then we have to prove that this integral here, where you have the function evaluated at the sine of x, multiplied by x, that this integral here can be calculated as just this integral over with here pi over 2, and here we have removed the x. This is one of these magic tricks that you can sometimes play by doing a change of variable. So here the change of variable is suggested is equal to this, so let's do that first, right? So suppose we do this change of variable in this expression here, so what we have is that x is equal to pi minus y, so dx is equal to minus dy. When x is equal to 0, of course y is equal to pi, and when x is equal to pi, of course y is equal to 0. Okay, so we transform this integral, the integral that we want, I, which is from 0 to pi of x f sine of x dx, right? We transform this into the integral from pi to 0 of pi minus y f of sine of pi minus y times minus dy. Okay, minus dy. All right. The minus compensates the change of limits here, so we can write here 0 to pi and get rid of this minus here. Now, the sine of the supplementary angle, which is that, is just the sine of y. Okay, remember, if you have a cycle like this, right, and you have an angle, any angle y here, okay, the supplementary angle is this one here, which has, well, if I had drawn it properly, like this angle, which is pi minus y, has exactly the same sign as this one, right? So this is the sine of y. So actually the integral we have here is pi minus y times f of sine of y dy. And we can separate this into two integrals. The first one is pi times the integral 0 to pi of f of sine of y dy. And the second one is the integral from 0 to pi y f sine of y dy, which is just the same integral as this one. So this is pi, this integral f sine y dy minus I. Okay, so we have this equation, I is equal to pi times that integral, right? From 0 to pi of f sine, it doesn't matter if I write y or x, because this is the integration variable. So the name we give it to give to this variable is irrelevant. Minus I. So we have obtained this equation. We can put this here, right? Adding to the right. So what we have is this, and of course, if we divide by 2, what we end up having is this integral, which is exactly what we have here. Okay, so you have a nice property that when you evaluate this function, right, this integral, all you have to do is to get rid of this x and just multiply by half the result of this other integral, which is of course simpler than this one. Okay, as an application, we have to calculate this integral here. Okay, so this, or the trick of that, is that we need to express this integral as an integral like this. And once we do this, then it's applying the previous result, right? Okay, so how do we do that? Well, we have to identify f of x. And for that, we need to re-express this. Well, let me just put it like this. we have to, in order to identify this function, what we have to do is to express the whole function in terms of the sign. But that is easy because the numerator is already a sine, and the denominator, the cosine squared, is 1 minus sine squared. Okay, so what we have is 2 minus sine squared. So what we have here is, well, that implies is that the function f is x over 2 minus x squared. All right. So we have found a function so that this integral here can be expressed like this, and according to the result we just proven, this is equal to pi half the integral from 0 to pi of f of sine of x dx, and f of sine of x is, of course, well, this one, which is this one, and that's the best way of expressing this function. So it's the sine of x over 1 plus cosine squared of x. And I said that this is the best way of expressing this because the sine here is the derivative of minus the cosine. Okay? So the derivative of minus the cosine of x. Okay? So what we have here is just an immediate primitive, okay? Is the arctangent of minus the cosine of x, because cosine squared is of course equal to minus cosine squared, right? Okay, so this is the arctangent of minus the cosine of x, okay, between 0 and pi. So what is that? This is pi half multiplying this, substituted out pi, cosine pi is negative 1, so this is 1, so the arctangent of 1, minus, and then we have here the cosine of 0 is 1, the arctangent of minus 1. But the arctangent is an odd function, so we can extract the sign out of the function, so we just have twice the arctangent, so what we have here is pi times the arctangent of 1, which is pi squared divided by 4. So that's the answer to the second part.